After every storm, when the clouds begin to clear, something magical appears on the horizon, a rainbow. A delicate arc of color stretching between sky and earth, it has fascinated humans for millennia. To ancient civilizations, it was a divine bridge, a promise from the gods or a sign of peace after chaos. But today we know that this phenomenon isn't magic at all. It's pure physics. The rainbow is the perfect harmony between light, water, and geometry. If you enjoy this educational content, please give a like, subscribe, and share this video with your friends. To understand how a rainbow forms, we must first understand what light really is. To our eyes, sunlight looks white, but in reality it's a mixture of many colors from red to violet. Each of these colors corresponds to a different wavelength. Red has the longest wavelength, violet the shortest. And because light waves of different lengths bend differently when passing through a medium, each color behaves uniquely. When a ray of sunlight enters a raindrop, it slows down and bends, a process called refraction. Part of the light reflects off the inner surface of the drop and then exits again. But by the time it leaves, the once white beam of sunlight has been split into a full spectrum of colors: red, orange, yellow, green, blue, indigo, and violet. This separation of colors is known as dispersion. Each drop of rain creates only a tiny part of the rainbow. But when billions of raindrops in the atmosphere all refract and reflect sunlight at once, they form the magnificent colored arc we see across the sky. To see a rainbow, you must stand with the sun behind you and rain in front of you. The angle at which sunlight reflects inside the drop is about 42 degrees. That exact angle determines where the rainbow appears in the sky. And since your eyes catch light from different drops than anyone else's, every person sees their own unique rainbow. In fact, the rainbow isn't located at any fixed spot in the sky. It's a perspective effect created by millions of light rays reaching your eyes at just the right angle. It's not an object. It's a perfect illusion made of light. When sunlight enters a raindrop, a fascinating process unfolds inside. A dance of light and water guided by the precise laws of physics. At the surface of the drop, the light slows down as it passes from air into water, which causes it to change direction. This is called refraction. Then, part of the light reflects off the inner wall of the droplet before leaving it again. By the time it exits, the light has been spread out into a fan of colors, forming what we call a spectrum. This happens because each color of light bends at a slightly different angle. Red light, which has the longest wavelength, bends the least, while violet light, with the shortest wavelength, bends the most. The result is a perfect separation of colors, what we see as the rainbow. Every single raindrop contributes only one color to your eyes, red from some, blue from others, depending on its position relative to you and the sun. But because there are billions of drops in a rain cloud, all refracting and reflecting light simultaneously, we perceive a continuous arc of colors stretching across the sky. To see a rainbow, three conditions must align perfectly: sunlight shining from behind you, rain or mist in front of you, and the right angle between them, about 42 degrees. This is why rainbows appear most often when the sun is low in the sky, early morning or late afternoon. When the sun is high overhead, the light strikes the drops at too steep an angle and the rainbow disappears. Sometimes, though, nature gives us a little bonus, a double rainbow. It occurs when light reflects twice inside each raindrop before exiting. Because of this second reflection, the outer rainbow appears fainter, wider, and with reversed colors, red on the inside, violet on the outside. Between the two arcs lies a darker region known as Alexander's band, first described by the Greek philosopher Alexander of Aphrodisias nearly 2,000 years ago. Each rainbow, no matter how often you see it, is unique. It depends on the size of the raindrops, the purity of the air, and the exact position of the sun. Even moving a few steps changes the set of droplets that reflect light into your eyes, creating a new rainbow that exists for you alone. That's why no two rainbows are ever the same. They are personal illusions of light, born in a perfect moment between rain and sunshine. While most people know the classic single rainbow, nature sometimes reveals something even more breathtaking: the double rainbow. It's one of the rarest and most stunning displays in the sky, and it happens when sunlight bounces twice inside each raindrop instead of once. The first reflection creates the primary rainbow, bright and vivid, with red on top and violet at the bottom. The second reflection sends light out at a slightly different angle, forming a secondary rainbow above the first. Because the light is reflected twice, it loses some of its intensity, making the second arc fainter, wider, and with reversed colors. Now red is on the inside, violet on the outside. Between the two arcs lies a mysterious dark zone, Alexander's band, named after Alexander of Aphrodisias, who described it in the 3rd century. This darker region appears because no light from the droplets is directed toward our eyes there. It's a subtle reminder that even in something as beautiful as a rainbow, geometry and physics dictate everything we see. But the wonders don't end there. What we usually perceive as a half arc across the sky is, in reality, a complete circle of light. The Earth's surface simply hides the lower half from our view. If you ever see a rainbow from an airplane, a mountain, or a tall building, you might notice something extraordinary. A full circular rainbow surrounding the shadow of the plane or observer. This full circle reveals the true, symmetrical nature of the phenomenon. This circular form is part of a broader class of atmospheric optics. When light interacts not with raindrops, but with ice crystals in high clouds, it can create other phenomena such as halos, sundogs, parhelia, and glories. A halo forms when sunlight passes through hexagonal ice crystals, bending at angles of 22 degrees or 46 degrees, producing a glowing ring around the sun or moon. A glory, on the other hand, appears as a colorful circular halo around the shadow of an airplane or mountain climber, caused by diffraction and multiple scattering of light in mist or clouds. These phenomena, rainbows, halos, and glories, all share the same foundation, the bending, reflection, and dispersion of light. Nature uses just 2 simple ingredients, light and water, to create a whole gallery of atmospheric masterpieces. Each time we witness one, we're not just seeing colors, we're witnessing light itself being sculpted by physics. The sky becomes a living laboratory, where geometry, motion, and refraction unite to paint something that feels almost supernatural. So next time you look at a rainbow, remember, it's not simply a decoration after the rain. It's a map of light itself, drawn in real time by billions of tiny droplets, all working together in perfect harmony. A rainbow is far more than just an optical phenomenon. It's one of the most powerful symbols in human history. For thousands of years, people across the world have seen it as a message of hope, a divine bridge, or a sign of peace after destruction. In the Bible, it represented God's covenant with humanity after the Great Flood. In Greek mythology, it was the path of the goddess Iris connecting heaven and earth. And in many cultures, it symbolizes balance between light and darkness, between nature and spirit. But science gives this ancient symbol an even deeper meaning. The rainbow is the perfect union of physics and beauty, where cold mathematics transforms into something emotionally moving. Every drop of water acts as a microscopic prism, splitting, reflecting, and recombining sunlight billions of times per second. In that endless repetition, nature performs an invisible symphony of light, precise, mathematical, and breathtakingly beautiful. From a scientific perspective, a rainbow represents the delicate harmony between order and randomness. The laws of optics never change. Light always refracts at the same angle, disperses in the same way, and follows the same equations. Yet no 2 rainbows are ever the same. Each depends on the size of the raindrops, the position of the sun, the observer's location, and the clarity of the air. Every rainbow is a one-of-a-kind creation, a moment that exists only for you. The rainbow also reminds us that understanding doesn't destroy wonder, it deepens it. Knowing how light bends, reflects, and disperses doesn't make the rainbow less magical. It makes it more extraordinary, because now we see not only the beauty, but also the elegance of the physics behind it. A physicist would say that a rainbow is the result of refraction, reflection, and dispersion of light. A philosopher might call it the meeting of chaos and order. A poet would say it's the smile of nature after tears of rain. But no matter how we describe it, the rainbow remains what it has always been, a bridge between science and wonder, between light and life. A moment when the laws of nature turn pure energy into art. Because a rainbow isn't just light bending through rain, it's light learning to dance.